Key functional effect of cocoa powder's inclusion in bakery products. Cocoa powder types. Mali 2000 classifies cocoa powder being made from cocoa mass by removing cocoa butter through means of pressing. Cocoa powder is derived from chocolate liquor by pressing a portion of the fat. SWOS 2009. There are two types of cocoa powders, natural and Dutch, covering 2006. According to Gislen 2017, cocoa that has been grown naturally is slightly acidic. The cocoa butter content for each type of cocoa powder can vary between 8 and 32%. It is believed that cocoa powder's main function is to produce chocolate-colored and flavored cakes, covering 2006. Dutch cocoa powder is darker than natural cocoa powder with smoother flavors, whereas natural regular cocoa powder is reddish brown with a fruity and robust flavor. Rees 2003. Dutching process. During the 1800s, a Dutch chemist and chocolate maker named Conrad Joans and Van Outen invented a process for removing cocoa butter from raw cocoa by using a powerful hydraulic press. Gislen 2017 and Gislen 2005 and Rees 2003. Alkalization process. This process consists of an alkaline solution, e.g. potassium carbonate, which is added to the cocoa nibs just before roasting. Afua 2010. Beckett 2000. Care must be taken, Beckett 2000, not to add too much alkaline, since cacao butter is composed of 3 fatty acids attached to glycerols. SWOS 2009, called triglyceride. The alkalization process raises the pH from 5.2, 5.6 to 6.8, 7.5. Afua 2010, and in some reports provides a broader range of pH, 5.5 to 8. Rees 2003. Beckett 2000 suggests that if the alkaline level is too high, one solution might be to apply a small quantity of ethanoic or tartaric acid after the alkalization process has been completed to reduce the pH level. Alkalization impact on cacao characteristics. Afua 2010 describes the effect of alkalization on modifying the cacao powder or cacao's liquor color and flavor, as well as raising the absorption rate of cacao starch by increasing the dispersion of cacao solids in water. Published literature, Rees 2003, agrees that alkalization increases cacao dispersion in liquid, resulting in consistency when added to cake batter. Cacao's powder color change is attributed to a chemical called polyhydroxyphenol, which is made up of epicatechin. Please see Figure 1 and 2, Beckett 2000. During the fermenting and roasting stages, these molecules react with other chemicals within the cacao and oxidize. This chemical reaction increases the number of color-giving molecules, hence making the cacao much darker. Beckett 2000. Beckett 2000 emphasizes that by altering and adjusting the pH level, moisture content, roasting temperature, and time, and many more color combinations are possible as a result of this reaction. Methodology. The recipe that was used in this bake trial was provided by University College Birmingham. Please see below tables 1 and 2. Given that cacao contains a starch that is hygroscopic and absorbs moisture from the batter, to ensure the cake's color change takes place from yellow cake to chocolate cake, it is necessary for the cacao powder and flour weight to be adjusted. Gislen 2017. The recipe's cacao powder's weight was set at 35% of the flour's weight. The formula that was devised by Gislen 2017 presents that flour weight must be reduced by 37.5% to compensate for the added cacao powder's weight. For all test bake samples, please refer to Table A and B. Dyer 2003 expresses the necessity of critically differentiating cocoa powders that have been processed with alkali solution at nib, liquor, or cake stages, and separate the purpose of alkalization into 3 categories, summarized in Table 3. And please refer to Table 4 for explanation of each method. Full-bodied warm brown has a cacao butter content of 52 to 56%. According to Beckett 2000, higher fat content in cacao butter results in greater color change in visual perception. See Figure 6. Moser 2015 explains that a cake recipe with a natural cacao powder pH 5.6 with acidic ingredients will require bicarbonate soda as its leavening agent since it is acid activated. Examining sample 1, it can clearly be seen that cacao powder with a pH of 7 offers the lightest shade of brown, and sample that offers the second lightest shade of brown is sample 3. Sample 4 offers the darkest brown color muffins. Please refer to table 6. Sample 1 muffins with baking powder only versus sample 2 muffins with baking powder and baking soda. Sample 1 has developed a light brown color because it has a higher level of acidity as compared to sample 2 that produced a darker brown color since it contains extra quantity of alkaline due to the presence of bicarbonate soda in its recipe. Sample 1 resonates with code G and sample 2 resonates with code D. The above results was expected since Dyer 2003 states there is a close relationship between color and pH of cacao powders. Please refer to Figure 3. Powders with light brown colors have a pH of 6.5 to 7, and sample 1 and 2 have a pH of 7. Hui et al. 2008 states that sometimes pH level above 7 is used to cause modifications such as color or flavor in chocolate cakes. Sample 3 muffins with baking powder only versus sample 4 muffins with baking powder and baking soda. Sample 3 has developed a reddish brown color because it has a higher level of pH since it has gone through the alkalization process as compared to sample 4 that produced a very dark brown black color since it contained the extra quantity of alkali due to extra 2 grams of bicarbonate soda in its recipe. Sample 3 resonates with code D and J. Sample 4 resonates with code B and H. Dyer 2003 supports the above baking test result that the pH of baked products with darker and red-brown colors can range from 7 to 8. Please refer to Table 8. Figure 7 and 8 show the cacao powder's color spectrum observation from light brown to very dark brown, starting at far right with sample 1, normal cacao powder with BP, sample 2, normal cacao powder with BP and baking soda, sample 3, Dutch cacao powder with baking powder, to far left, sample 4, Dutch cacao powder with baking powder and baking soda. However, for recipes where the cacao powder used has a pH above 7, it will require baking powder because there is insufficient acid to activate the baking soda, hence unable to generate enough carbon dioxide. Therefore, BP is required to boost the extra lift. It is very crucial to balance the right amount of acid and alkaline in the recipe. Coven 2006 clarifies the necessity to apply the neutralizing value, which is the quantity of baking acid required to release all the available carbon dioxide from the sodium bicarbonate. Please refer to Table 8. The impact of different levels of pH on the muffin's finishing color where sample 1 with pH 7 is compared against sample 3 with pH 7.8 and sample 2 with pH 7 is measured against sample 4 with pH 7.8. It is clear that both sample 3 and sample 4 have darker shade of brown, with sample 3 being a dark reddish brown color while having developed better open crumb structure. Sample 4 has also higher height with the difference of very dark brown black color. By examining the muffin's crumb structure, see figure 10 and 11, it is evident that higher levels of pH enhance the performance of leavening agents. According to Dyer 2003, although the neutralizing value of acids in cacao powders has flavor benefits, it does affect the behavior of baked products containing bicarbonate soda and baking powders. Dyer 2003 emphasizes the higher pH interferes with raising agents, causing larger air bubbles, as seen in figure 10 and 11. Binion and Bamford 1997 explains that when sodium bicarbonate that has not been neutralized by the acid in the muffin's batter, the excess bicarbonate soda will increase degree of browning of sugars during baking. This was seen clearly in both sample 3 and 4. Please refer to figure 9. Binion and Bamford 1997 explains Maillard reaction is encouraged at higher pH level. This type of browning also promotes open crumb structure that was seen as sample 3 and 4. Please refer to figure 10. Due to high pH level interfering with leavening agents, Dyer 2003 emphasizes that the higher pH interferes with raising agents, causing large air bubbles. The most commonly used alkali solutions are sodium hydroxide and potassium carbonate. Lee et al. 2013. Results from their research show cacao powders demonstrated a darker color when potassium carbonate was used as the alkali solution. Lee et al. 2013. Since potassium carbonate and sodium hydroxide have different strengths, this has direct impact on Maillard reaction. Lee et al. 2013. Data from their trials show sodium hydroxide solution has a strong neutralization value. Therefore, it can generate a red-brown color and chocolate flavor in cacao. Lee et al. 2013. Cacao with a dark color is associated with a lower polyphenol content. Lee et al. 2013. Clare 2014 clearly states that baking soda is the key raising agent that increases browning during baking. Maillard reaction is the chemical reaction between the amino acids of protein and sugar. Protein from flour and eggs from breakdown, which combine with sugar to develop compound flavors, and bicarbonate soda provides the optimal state for this reaction with higher level of alkaline. Hence, baking soda is the primary choice. Clare 2014. Lee et al. State that the content of polyphenols was reduced as the degree of alkalization increased. They concluded from the research that content of some flavors compounds were altered under different levels of alkalization. Cacao powders with a heavy degree of alkalization had the lowest ratio of monomers and anthocyanins to yellow-brown polymer content. Lee et al. 2013. Please see all related references on this page. Thank you.